that's the thing you have to think about. Okay, Grant, girls. Okay, shh. This is the maximum existence theorem. When you're on the exam and you're reading the problem and it starts talking about when is the particle furthest to the left, then that's a minimum, or furthest to the right, that'd be a maximum, you have to be thinking, oh, I wonder if I can use this theorem. If it's a closed interval and a continuous function, you can. So what this does is guarantees you will have both. And I'll be a little redundant, but that's okay. It's a guarantee. It's a promise. Guarantees both a maximum and a minimum value. Of the function. So I'd like to have this. Otherwise, there are other tests that you can do, and you'd have to look at the graph. And if it's a non-graphing calculator, it makes life hard. Even if it is on the graphing calculator section, you have to find a max or minimum. You have to show the calculus. There's only 4 things that you can use on your calculator and not show work. That n derive, the FNINT, which is an antiderivative, finding zeros of a function, and finding intersection points. And what happened last year, it happened to be the BC one, they were doing an integral, and some of the students had the CAS calculator. The thing is when you do the antiderivative, and it was doable, they wanted you to do the FNINT, the numerical one, and which everybody has access to, but some of the students used their special ability in their calculator to find the antiderivative and evaluated it, and they did not give them the points for that. I disagreed because I looked at that and I said, I'm pretty sure I could go from whatever the function was to their answer with the antiderivative just in one step without showing any work. So there really was no proof that they had used the calculator. And even then, since they had to use a calculator to find the answer, what difference does it make? It still was equal access for everyone. So they still didn't do it. They took all the points off. Wasn't real nice. So it just depends on the chief reader. Because we did talk to them. I made a complaint. When they do the briefing of the problems, you sit in a room and we be like this. We might even be more squished together, but there's a whole bunch of us in the room. And they'll talk about it. Grant, don't do that. Anyway, they'll talk about the problem. You're given the scoring rubrics, and you take notes. And this goes on for 45 minutes, an hour at least. You write it out as fast as you can. And the one rule is no questions. Because we'll all be like, and they'll go, nope, no questions. This is the way it is. So you can't argue with them at all. They tell you how you're going to grade it. You'll get questions when you start getting into it. And then that's why you have table leaders. Okay, so let's do this little theorem. And they might ask you, you might have to state the theorem. Somehow you would have to demonstrate that you're using the theorem, using the table of values. You might want to write down it's continuous, closed interval. So then they know that you really do know the theorem. Remember, you have to convince the reader. Now, what do we have to do to guarantee the maximum? Function has to be what? Continuous on a closed interval. And the closed interval we called AB. When I see that I'm going to look for a maximum value and it's a closed interval, I don't even necessarily look for the continuity piece. I go, oh, that's great, because this is going to be easy. Because we're going to write down all the steps of what you do. So then the function must contain both a maximum and a minimum. It's not an or, it's both. Value of the function. I really should have written in of the function, because it's the y value. Okay? That's the theorem. How do we use the theorem? And I don't know if you started your homework. There are some tricky problems in there. Where will the max and min values occur? I have, unfortunately, some redundancies on my smartboard. Where what? The derivative equals 0. I'm sorry, I just couldn't quite get that. And where else? The derivative does not exist. Those are the only places, and where else? Endpoints. A and B. So if I'm looking at a function, the only place I'll find a maximum or a minimum is when that derivative is 0. Oh, let's put it on the corner. Or undefined. And then yesterday I said, You wouldn't have vertical tangents. Yes, actually you can. Vertical tangents is another place where you might have a max or min. Well, no, I'm saying that wrong. You will find vertical tangents, but you aren't going to have a max or min there. But you aren't going to necessarily know. You just have to evaluate. Okay, so those are the only places I can get max mins. Now I'm going to go to the next page. Just repeat that because I'm going to use that in a second, because I'm redundant on here by accident. F prime equals 0. F prime does not exist. And A and B. Okay, how do you know if you have a maximum or minimum? How do you know which one's the biggest and which one's the smallest? Make a chart and evaluate your function, f of x, at your critical points. And then it's whichever's biggest or whichever's smallest, and just ignore all the rest. And that's all there is. So my next slide, we'll just quickly summarize it. You ready? Okay. Except that I have to slide this. There you go. So what are the steps? First, see if it applies. Max, min, existence theorem. Does it apply? I look for the closed intervals. That's how I do it. Then the only calculus is to find where the derivative is 0 or f prime does not exist. And then where are the other critical points? And then you find the endpoints, or you have the endpoints. And then how do you know which is the biggest one? Just evaluate, not f prime, but evaluate f of x at each critical point. That's my chart. Max min, does it apply? Do I have a closed interval? Does it apply? It's the IT. Sorry. Evaluate f of x at your critical points. Closed interval and continuous function. So it's really, it took me a long time to get through all this yesterday, but that's really all there is. So if I look at my example 1, is e to the minus x squared continuous? Is it on a closed interval? Yes. Okay, so it applies. Next step is to find where the derivative is 0 or it doesn't exist. And then I have to evaluate everything, yes. Then if it's not continuous, that will put us into section 4.3. That'll put us in section 4.3. And that's what I didn't like about the book. They don't have closed intervals for all those problems. So what you have to do right now is use your graphing calculator and look at the picture. And we can look at the picture of this one. Now, on the exam, even though I can look at this picture, I can draw it out, I can actually find the maximum quite easily, because I know what the graph looks like. I would still have to show the derivatives and all the work. That's what they expect to see. They won't give you something that's easy. So, how do you, in some of your thinking, well, how do you know what it looks like? Well, what's f of 0? It's 1, right? You okay with that? And I'm going to go one step further. I'm not going to evaluate f of negative 2 and f of 2. I'm going to say what happens to my function as x gets really big. This is e to the minus x squared. How else could I write e to the minus x squared so that I can do this a little bit easier? It's 1 over e to the positive x squared. So this is where you're going to get a little challenge with your algebra. Negative exponents don't make it negative. They just put it down there. So what happens when x goes to infinity? It gets really tiny. So the limiting value is 0. Is e to the minus x squared ever negative? Never negative, because e to the x is never negative. So it's always a positive number. So what does this thing look like? Well, it's 0, it's 1, and it's going to go off to 0. Goes to 0 pretty fast. My guess is it's a nice smooth function. It looks something like that. So obviously, there's my max. The question that comes in is what somebody asks is, what if it's negative infinity to infinity? Is there a minimum? No. So the only way to know is to look at the graph. The only way. On the exam, they're probably not going to give you the function anyway. They'll give you the derivative. So you'll have to do other things. So you have to use the calculus. Okay, let's do the problem then. So I don't know how many critical points there are. I know I have at least 2, maybe 3, maybe more. So I'm going to do my chart, make it that big. I love that chart. Okay, so I like to do what's easy first, x and f of x. What are the first 2 critical points? Negative 2 and 2. Whoops. Okay, so these are the endpoints. Chart does not work if it's an open interval. Unless you know something doesn't turn around. You know what the graph looks like, then it might be helpful, but generally it just doesn't work. Okay, now what else do we have to do? We have to find where the derivative is 0 or where it doesn't exist. So if f of x is equal to e to the minus x squared, we have to find the derivative. What's the derivative? E to the minus x squared back again times chain rule, negative 2x. Okay? And we want to know where this is 0. So I'm going to put my 0 over here. And this is 0 product property. The product of these 2 factors gives me 0. Well, then either e to the minus x squared has to be 0, or minus 2x has to be 0. Well, a to the minus x squared is always greater than 0, so that's not going to work. Are there any places where the derivative doesn't exist? Remember, e to the minus x squared looks like a nice smooth curve. Minus 2x just looks like a line. They're both very nice functions, so there's no place where the derivative doesn't exist, but there is a place where the derivative is 0, x equals 0. And it might be there are no places where the derivative is 0. Now, I do have to check these points and make sure they're in my interval, in which case they are. Okay, that was the only calculus I had to do. The rest is just finding the value. What the maximum existence theorem does is it gives you the places to look for the maximum and minimum. And then the way to find it is to find the value of your function. Well, I do easy things first. What's f of 0? F of 0 is not 0, it's 1. What's f of 2? I'm going to do easy first. It's e to the negative 4, which is 1 over e to the 4th. How big is e? 2.7. Let's make it a whole number. It's pretty close to 3. What's 3 to the 4th? 81. So that's like 1 over 81, which is pretty darn small, right? If you have $81, you have an $81 bill you have to pay, and you have $1. You don't have a lot of money to pay that bill. It's pretty small, right? What if I put the negative 2 in here? It's e to the minus negative 2 squared. I must use parentheses. It's the same thing. So it's 1 over e to the 4th. Okay, now let's answer the question. Is it even or odd? Or neither? It's an even function. Look at my picture. It's even. If you put in minus x, you can do that. Because f of minus x is equal to f of x. Which then, if I'd thought about that, I could have just done this one and then written that one down. So the reason we do even and odd is it makes our life a little bit easier. Okay. I want to find both the maximum and minimum value. What's the maximum value? 1. Where it occurs at 0, at x equals 0. Occurs at. It doesn't hurt to say it, assuming you're right. But if they don't ask, why write it down? Okay. What about this one? What's the minimum value? That's where. What's the value? Minimum is 1 over e to the 4th. At both places, x equals 2 and negative 2. I'm going to write value too. Okay? That's all you have to do. If it's an open interval, you're going to have to get your graphing calculator out. But if it's a closed interval on this homework assignment, then you can just use this theorem. Evaluate your endpoints, and if you want to use a calculator to evaluate your endpoints, fine. I don't care, because that's not my goal. My goal is to see if you know how to use the theorem. Could be that it's on the non-calculator part, but it shouldn't be too hard to evaluate. Now we're going to skip to the problem we skipped yesterday, because it's a nice little problem, and then we can do maybe a homework problem. I don't get to all of these. That would be one. See, it's minus infinity to infinity. So can you use this theorem? No. All you can do is find where the derivative is 0, look at the candidates. You could evaluate it, and you're going to have to look at your graph to see what it's doing. Honestly, I have no idea what that's doing. But let's do this one. That, again, same thing with that one. You're going to have to graph it. But this one, we actually graphed it. I think I've been graphing it wrong all these years. Or else I typed it wrong. It's on yesterday's. But you could put it on the back of the green. It's on yesterday's. I don't care where you put it. It's for you. Yeah. It's written like that because then it's easier to differentiate. Not necessarily easier to figure out what it looks like. It's a strange looking function. We graphed it. So I don't remember how many critical points there were. So let's just put our little table there. Because I like to see that. I like to fill in what I know how to fill in. So here's x. Here's f of x. X is -1 and 1. We'll evaluate those later. Is that okay? Now I'm going to look for the derivative being 0 or doesn't exist. So guess what we have to do? We have to find the derivative. I'm going to rewrite it here. Equals 6 times x to the 4/3 minus 3 x to the 1/3. Easy to lose parts. I lost the 3 partway through the problem. Not a good thing. Okay, so what's the derivative? Okay, so I'm going to do little pieces. I'm just going to take that derivative, which is 4/3. You're right. X to the what? 1/3. Minus 3 times, because some of you aren't real happy about fractions. So 1/3, which is going to give me 1, times x to the what? -2/3. So f prime of x, somebody was already telling me 24/3 is just 8. You know what else? I don't like that x to the 1/3. It doesn't feel comfortable for me, because I'm not sure what it looks like. But when I write it this way, I have a better feel for what that looks like. Do you know what the cube root looks like? It looks like the square root. Can you input negative numbers into the cube root?
Yes.
Subtract 1/3 minus 3/3. Yes, you can do negative numbers. And that's going to go. So it's minus. Now, what's the negative mean? 4/3 times 6. What's this going to do? It's going to go in the denominator. So it's the cube root of x squared. That's your derivative. I feel much more comfortable when I look at that than the one above it. Because now I can look to see where f prime does not exist. Ask. If it would be what? I multiplied. Okay, Adam, where does this derivative not exist?
It exists when the cube root of x squared is equal to 2.
Okay, because you can't divide by 0. Cube root of 0 is 0, right? So it does not exist at x equals 0. That's a critical point. Those are the easy ones to find. The only problem with the derivatives, where are you going to get these, is when the derivative, or the denominator, I mean, is 0. It's a domain problem for the f prime. So I'm going to put that up here. That's 0. That's f prime
-1 and 1.
does not exist. Pardon? Because those were the endpoints. That's a different problem. Okay, and now here's the hard part, the algebra. The derivative wasn't too bad, but we have to set this derivative equal to 0. And this is not easy to see by inspection, I don't think. You can use fractional exponents. I don't care. I just think it's easier. It's easier for me, at least. And I think it's easier for most of you to have them more like a root, and I missed my square there. That would have been really bad. Okay. Oh, well, here's what I'm going to do, because it works all the time. I'm going to take one of those terms and put them on the other side, and I'm going to cross multiply, because I have a proportion. So I'm going to add a positive 1 over cube root of x cubed, x squared, sorry, to both sides. We already know x can't be 0, so we're okay with that. Okay, so what am I going to get? 1 over the cube root of x squared equals 8 times the cube root of x. And that's really over 1. How do you solve a proportion? Yeah. You know, and they're going to give you things that work nicely. So when we multiply that out, I'm going to have 8 times the cube root of x times the cube root of x squared, and that's equal to 1. Now, do you guys remember this from algebra? If you have the square root of a times the square root of b, that you can write that as the square root of a times b? Well, you can't if you have negative numbers for the square for a and b, but we're not dealing with imaginary numbers, so we don't have to worry about it. Get for reals. Or positive numbers, not negatives. Okay, what is this? That's the cube root of x what? Well, what does that equal? What's the cube root of x cubed? X. Equals 1. X to the first times x squared is x to the third. What's the cube root of x cubed? And if I had a squared there, I was in trouble. Okay? And then so x equals what? 1/8. I don't think you could have guessed it. Up here we said it equals to 0. Remember? Here's where we set my derivative equal to 0. And then we had to solve. You could clear out fractions by multiplying by this. I kind of like my method. There's a variety of methods. And this is f prime equals 0. Okay, let's start with the easy ones. All we have to do is evaluate it. That was all algebra, by the way. The only thing that was calculus was finding your derivative. So what's f of 0?
0.
That's 0. Now, let's do the next easiest one. What's f of 1? Well, the cube root of 1 to the 4th power is 1. So it's just 6 minus 3, so it's 3. Now, to do the negative 1, that's a little trickier. It's 6, and it's negative 1 to the 4/3 power minus 3, and it's negative 1 to the 1/3 power. Well, when I cube, well, let's do this one first. What's the cube root of negative 1? Negative 1. But here I'm going to cube root my negative 1. I can cube root it first and raise it to the 4th power. Any negative number to the 4th power is positive. So that's 6. So I get 6 plus 3 or 9. Okay? So now we still have to do 1/8. That's going to be fun. So it's 6. I prefer to do it this way. It's the cube root of 1/8. And then I'm going to raise that to the 4th power. Because I can switch those around. It doesn't matter. Minus 3, and it's 1/8, and it's the cube root of that. So let's do the easy one. What's the cube root of an 1/8? Well, the cube root of 8 is 2. The cube root of 1/8 then is 1/2. Now, I'm going to take the 1/2 now and raise it to the 4th power. So it's what? 1/16. And now we have to get common denominators. Oh. Okay, let's reduce that. Yeah, what does that reduce to? 3/8. No, I divide by 2. Minus 3/2. And now I got to get common denominators. So this is times what? 4. So it's 3/8 minus 12/8. No, negative 12 and a positive 3. Okay. A positive 3 and negative 12 is negative 9/8. Okay? So which one's the biggest? 9. Okay, so this is the maximum value. And what's the minimum? Negative 9/8. Do you not get it? Ask. Okay. It is a lot of steps. Is it continuous on a closed interval? Yes. And I write down my endpoints because I know I have to do that. It is continuous on a closed interval. Then I find my derivative. That's the only calculus that's there. And then I look where the derivative is 0, which makes me have to do some algebra. I look where the derivative is undefined, which is easier. And I evaluate everything. Now, would you like to see what this looks like? Well, first off, well, if I try to make a sketch, at negative 1, I'm up at 9. At 0, I'm at 0. At 1/8, I'm down here at negative 1 1/8. And then, and I know that that's a minimum, and I know that's a maximum, and then I have to do 1 and 3. Now, it's going to come into 0 like this, but now why does the derivative not exist there? There's no break in the graph. I can't get a cusp out of it. I can't get a cusp, but I can get a vertical tangent. So let's look at the picture, because it's kind of cool. I'm going to actually get you the real picture. Okay, so we're going to clear that out. Here's my y equal to. It's all typed in there. And I graph it. And there it is. So it's coming down. It's coming down like this, and it's a vertical tangent. It's bending down, and then it's going to change what we call concavity. I don't know if you... And then it goes back up. It's a strange-looking graph, isn't it? It's definitely what? Okay, so if I turned off the axes, I think you could see the vertical tangent coming in there. There it is. There's your minimum, and there's your max. Happens at the end point. Okay. What about a homework problem? I did 11 in the other class. We can do it in here. 11. It's on the board here. What's this? Is that 17? Okay, let's do 11 first. We'll see what we get. And that was between 1/2, negative 1/2? Okay, at 4? Okay. I will need my calculator to evaluate this. I tried to estimate, and I'm pretty close, but it's not close enough. So if they were to give you a problem like this, it would have to be in the calculator section, because there's no way you can estimate this and get it close enough, unfortunately. So here's x, f of x. What's x? 1/2. Okay, let's do the endpoints. At 4. Let's even evaluate them right now. What does this 1 over x do to my fraction? It reciprocals it. So it's 2 plus the log of 1/2. Well, the log of 1/2 is equal to the log of 1 minus the log of 2. So this 2 is getting smaller, because it's subtracting it. What's the log of 1? That's 0.691. So it's smaller. So it's like 1.3. Okay? What about the 4? It's 1/4 plus the log of 4. But the problem is I don't know what the log of 4 is. So my estimate first time through was log of 1/2 is pretty small. Log of 4 is bigger than we think. So let's find out. I have to use a calculator because otherwise I'll get it wrong. So let's do 2 plus the log of 1/2. And on the exam, there'll be tons of logarithms. So that's 1.306. Okay, I got 1.3. That's close enough. Now let's do 4, or 1/4. 1 divided by 4 plus the natural log of 4. 1.63. So they were close, but so this is 1.63. Okay, so you would have to have a calculator for this. Okay, that was the easy part. There was nothing really to do there. And now what do we have to do? Take the derivative. Do you remember the derivative of 1 over x? That's right. Because the derivative of 1 over x is x to the negative 1. Well, that's equal to negative 1, x to the negative 2. I've done it so many times, I've memorized it. Come spring, I will just automatically write it down. I just did the derivative of 1 over x. I haven't finished. X to the negative 1. I don't see a half there, do you? Okay, what's the derivative of the log of x? Okay. I like to find the singular points first because they're obvious. Where does this derivative not exist? 0. I'll put it in here, but now I'm going to check up here. It's not in my interval. It's not in my interval. It's not, and 0's not, doesn't even work here, does it? That's why it's not in the interval. But you have to check. So that was not going to be a candidate. These are places where it might happen. So now we have to solve this thing. Because what's f of 0? You can't do f of 0 on either one. It's 1/2 to 4. Does not include 0. What? We looked where the derivative does not exist. F prime does not exist at x equals 0, but x equals 0 is not in the interval.
Okay, move on.
Okay, now we have to know some algebra, because we have to set what we have left here equal to 0. I could clear off fractions, or, because if I just add 1 over x squared to both sides, I get a proportion. Now, you guys, when I solve equations, I'm still in the same one. But now what am I going to do? Grant? Now what am I going to do? X squared equals what? X. Now, this is not the same equation as my original one. Listen carefully. This is not the same equation. The candidates for here might be solutions there. I get extra candidates because you can't divide by x. X is a variable. X squared minus x equals 0. This equation has x equal to 0. Oops, that's a 1. This solution here is x equals 0. X equals 0 does not work there. So you have extraneous solutions when you transform an equation, because I know how to solve that one. All I do is change it around so I could find one I could do, that's all. So then this is 1. That was not that bad. What's f of 1? It's 1 plus the log of 1, but the log of 1 is 0. So it's 1. So which one's the minimum? That's the minimum value is equals 1, and it occurs at x equals 1. And what's the maximum value? What's the biggest one over here? 1.63. And the only way you're going to get good at this is to just crank through some problems. You want to look at 17? Well, that's homework. Yeah. You might have to read it to me. Well, I might have it.
The minimum is 1, 1.
1. Now be careful, don't give an ordered pair. You have to say the minimum value is 1, and you can say at x equals 1, but the problem is, if it, those turned out to be the same, so it's no big deal. Oh, 17, not 15? Oh, 17 is kind of like what we did today. Do I need to do 17 or should I do 15? Adam. Adam, have you done your homework today? No. I could tell by the look on his face. Okay, so this is, I call this a silly problem. We are going to do the work to practice. Because what's the maximum value of that function? 1. And the minimum value is -1. I don't need to do any calculus to know that. But if I want to get this on the, I want to get my points on the exam, I'm going to have to do the work. So we'll just do it for practice, because I don't know what you've done in terms of solving trig equations. Okay, so let me get my chart out here. I really have no idea how many there are, so let's make sure I got it. Okay, so I have x, y, and x is 0, and I have 7 pi over 4. So we'll have to evaluate those. Do you want to do them now? What's the sign of 0? The sign of what? All you've done is shifted the sign graph. That's it. What is that? What's the sign of 45 degrees? 1 over the square root of 2. Because it's the sign of 0 plus pi over 4. What's this other one? It's the sign of 7 pi over 4 plus pi over 4. Oh. That's 7. Yeah. That's 8 pi over 4, which is 2 pi. What's the sign of 2 pi? 0. Okay. I don't have any negatives, but I know sine gets negative, so I don't think I've got a maximum in either one of those. So let's find our derivative. And this derivative was easy, right? Not negative. It's the cosine. This isn't the problem. The problem is, how do you solve that for 0? Cosine is clearly defined everywhere. There's no places where the derivative doesn't exist. But I want the cosine of this. And I don't know how much you did in pre-calc last year of solving trig equations. I want that to be 0. So I'm going to draw a cosine curve because I forgot where my zeros are. Did you guys forget what your zeros are?
No.
Oh yeah, we didn't do this.
What's the derivative of x? 1. And what's the derivative of a constant? 0. So this is pi over 2. That's 3 pi over 2. Okay, I've got to look between pi over 4 and 7 pi over 4. So this is my angle. So whatever my angle is, my theta has to equal pi over 2. Could be 3 pi over 2. What's the next one? 5 pi over 2. I'll write out enough so I know I get them all. Pardon? Right. Theta. The cosine of some angle is 0 at these places. Well, this is a shift. So I'm just going to put theta back in here. X plus pi over 4 is equal to pi over 2, and I'm going to solve that. What's the x value that gives me that? So x equals pi over 2 minus pi over 4. If you think of it this way, it's pi times a half minus a fourth. It's easier to think. I subtracted pi over 4, and I factored out the pi. All you do is add the coefficients. 1/2 minus a fourth. What's 1/2 minus a fourth? You don't need to do common denominators. You know this. Ryan? Because the cosine of some angle is 0 at pi over 2, 3 pi over 2, and 5 pi over 2. Yeah, I could keep going. 7 pi over 2, 9 pi over 2. I could keep going. But I'm limited, thank goodness, by my domain restriction right there. Okay, so I'm going to put that one up there. That's pi over 4. Are there more? Well, guess what? We got to do this again. The cosine of my angle, I think I can do it right here. Cosine of x plus pi over 4 has to be equal to 0. I called that theta. I don't care what's in there. My angle now is going to be 3 pi over 2. Well, my angle is x plus pi over 4. It's just a shift. That's all it is. Translation. Now what do? Solve for x. What is x? Well, it's 3 pi over 2 minus pi over 4. Now, if I factor out the pi's, I think it's easier for you to see. It's pi times 3 halves minus a fourth. Well, how many fourths is 3 halves? Oh. Times 2, it's 6. So it's what? 5 pi over 4. You may be required to do something like this. And I should check to see if this other one, 5 pi over 2. So I'm going to do this. And let's put it over here. So I have room. X plus pi over 4, I just want to make sure I get them all, is equal to 5 pi over 2. I've got a great practice problem for you to try. It might be a quick problem where you have to do something like this. Oops. Minus pi over 4. Let's factor out the pi so I can see my fractions. So it's 5 halves minus 1/4 times by 2. That's right. That's x equals 9 pi over 4. Is that in my interval? No. So good. We can stop. Okay. We're almost done. I have to do as many times as long as all my answers fall within this interval. Where's my interval? Right here.
The only one that falls into the interval is pi over 4.
And 5 pi over 4.
5 pi over 4.
That's smaller than 7 pi over 4. Okay. So all you have to do is evaluate this. What is the sine of, and if you think about it, you're just shifting 45 degrees. It's pi over 4 plus pi over 4. What is that?
90.
That's 90 degrees. What's the sine of 90? 1. Okay, what if I do sine of 5 pi over 4 plus a pi over 4? That's the sine of 6 pi over 4 reduce the sine of 3 pi over 2. What's that sine? -1. Had they made the interval smaller, it wouldn't have happened there. 270. All the way down, it's negative. So, where's the max? Or what? Not what is the max? Not where. But I knew that before I even did the problem, didn't I? If this had not been included, then I would be looking at something else as my minimum. But it just depends on where I drop my interval. Right now it was included, so this is the minimum. Is that okay? It's not that bad. There's a number of steps, but it's not that bad, really. Where's the problem? More than anything, it's the algebra, isn't it? Yeah. That's going to be the problem. But we'll work on it. When you walk out of here, you will be